Okay, clicker time. Let's see how you do. Rock and roll. Rivers and floods. Oh, there it is. All right. Take your pictures. And let's see, this is Thursday, so you just had this on Tuesday. Let's see how you did. And the first question is, floodplains are flat surfaces adjacent to rivers formed by deposition during floods. Now, wait a minute. What do I do? Oh yeah, here it is. Poles are open, you're firing away. Go, go, go. 50, 60, come on, 70, 80. Get in there. Come on. Come on. 100. All right, firing away. Good. I'm not too late. Hi. 114. Come on. Keep going. Keep going. I'm missing a few people today. All right. 118. Very good. And now I got the countdown, Charlie. All right. There we go. 10, 9. Is that right? Okay. 5 more seconds. And you said, ooh, wow, 97% said true, and that's right, absolutely. What if I turn this around and said floodplains are flat surfaces formed by erosion? False, okay. You'll see it either one way or the other. Excellent. The shallow part of a stream occurs on the outside of the turn. Ooh, floods are open, that's a little harder. You have a turn in the stream. Where is the steepest part? Where is the shallow part? Is the shallow on the outside? And you're firing away, and there's the countdown. Real exam questions. When you're out water skiing, do you ski toward the inside or the out? Yeah. And, okay, 72% said false. Really? Way to go. Would this face try to get you? Sometimes I have to. If you're in that 28%, you just got a little bit backwards, okay? Take a picture. The role of erosion is greater than that of deposition at high elevations on a stream's longitudinal profile. Remember that? Longitudinal profile is the elevation with distance. It's concave downward. And we found that the upper, the middle, and the downside were significantly different in the features that they have. Okay. So what about erosion and deposition? Up, the poles are open. True or false? And I'll start the countdown. Here we go. 6 more seconds. Hurry, hurry, hurry. Got 20 more of you. Doesn't matter. This is not for grade. You get your participation saying anything. 85% said true. And that's right. Ultimately, way down on the profile, where your old age stream. I'm an old age stream. Erosion and deposition are equal. That water's moving. Okay, moving out, moving in, moving out, moving in. Okay? But way up on the profile, headward erosion, it is carving and digging. There's no floodplain. That's deposition. All right, no floodplain. It's eroding, carving, V-shaped valleys, waterfalls and rapids. Let's go rafting. Chico, California. Did you like that one? Watch it till the end next time. Ha-ha. Erosion by a stream occurs mostly on the outside of a turn. Would this face lie to you? No poker face here. But maybe that was a poker face. I don't know what you're going to do now. I got you rattled, but you got 6 more seconds. Come on, 20 more of you. Hurry up, hurry. There you go. And you said, 81% looked at me and said true. And of course, if I put inside the turn, you'd say false. All right, good job. Erosion and deposition are equally balanced in the, oh, well, were you just listening? In the downstream portions of a stream longitudinal profile. Okay, there you go. You got 10 seconds. Erosion and deposition are equally balanced. I hope I see something here. And you said, woo, didn't I just say this? Some of you weren't listening to me. It's true. I said just moments ago, I forgot this question was coming up. Way down on the profile where it says old age stream. I'm old. Everybody just said that. You were listening, right? You were. And erosion and deposition removal. That water is moving in and out. All right? Okay. A river's width, depth, and velocity all increase downstream. Downstream. You multiply width times depth times velocity, and you get what? Fill in the blank. Width times depth times velocity, the amount of water moving through. What do we call that? Discharge? Okay, discharge, write it down. And now the countdown here. Here we go, we're just trying to do a true-false question, but all those factors relate to the total amount of water. Do they all increase downstream? True or false? And you said, 90% said false because Dr. A has trouble making a lie. But sometimes I do. And you got that one right. 90% are true. All right, good job. The average annual probability of a 50-year flood. A flood so big it has to happen in 50 years, where everything converges. And you get a whole lot of discharge coming in. At a given location is 2%. All right, I will now open the polls. I will now start the countdown. Look at you, rock on. 80, 90, 100, you're in, you're in. 5 more seconds. Just a few more of you. Well, I think. Are you getting the green light? 83% said true. And that's great. Okay? That's the correct answer. There's the session data. That says you're in class. Way to go. Save it. Put it there. Open recent. All right, that's pulling up. So you got your midterms, or you're getting them back this week. Average grade was 76. What I forgot to say, and I said that's about on average for the first midterm. That's also most likely the lowest grade you will make in this class. Your next grade, midterm 2, I see this every year, is higher. All right? You've also got a PowerPoint to do. You've also got a term paper field trip to do. You've got a lab grade coming in. It's going to be higher, and you're going to ace that final exam. All right? So if your grade on midterm 1 you're not comfortable with that, that's good. I like that. That's a challenge. But do realize, on average, what I see every year is that's the lowest one. You're in, you're learning. I got to be in class to see this first. All right? I got to be engaged. I want to take notes. I need to review more. I need to go see Dr. A's office hours. How many of you have been to my office hours? Or in my office? I know some of you have, and a whole lot of you haven't. And I sit there, and it's so quiet all by our lonesome. And I also have an open door policy. So you just come in that earth science office. You know where it is? Right downstairs. Go in and walk right past the reception desk. Don't stop there. That's not a reception desk. It's just there. Hey, come, look to the left. That's my office down to the left. If it's open, you come in. Dr. A, can I come in? Yeah, get in here. All right? If I'm busy at the time, I'll tell you. So get in there. And a whole lot of you need to come see me and talk about how to improve your grades. Because that was a whole asymmetric distribution of grades. So a whole lot of you went down where you shouldn't be. And I want to work with you. Okay? Woo! All right, so today, air pollution and global warming. Oh, more scary stuff, yeah. Hey, who's that? Somebody just did their clickers and left when my head was down. All right, so this world, our wonderful planet, our Earth, been here for 4.6 billion years. You've only been around for 2 million years. Almost all of Earth time, this planet didn't have you to deal with. We finally show up. And for most of our time, 2 million years, our populations were so small and on another continent. We had started affecting things in Africa. We spread into Asia and Europe. We finally settled the Americas, not till 14,000 years ago, but our populations, as you know, stayed small. So for 2 million years, our populations were so insufficient on this planet. Finally, in 1830, right, we got our first what? Billion. And what are we getting to this year? 7. Yeah, wow. You got to quit reproducing. And so suddenly we're crawling all over this planet. We're running out of water, we're running out of materials, we're running out of energy, and we're polluting the water and air. This planet is choking. And you've heard this. Air pollution and global warming. I had never been to California before until I got a job there. In 1975, I arrived in perfect health, and immediately, I love running, always been a runner, and immediately, for the first time in my life, asthma. Asthma. What is this? Exercise-induced asthma. How many of you have asthma? Oh yeah, a lot of you. All right? It's choking, scary. All right? Now, I don't. In fact, gradually the air in LA got better. All right? We passed the Clean Air Act. We passed the Clean Water Act. All right? There's a lot of things that were polluting our air and choking us, affecting our health. But a lot of you still have asthma. Okay? Things have gotten better. Only in developed countries. The rest of the world, and most of the people, are suffering. It takes good laws and good leaders. Are you that? One person can make a huge difference. Air pollution and global warming. Somehow that's stretched. We've got to figure out why. All right? I have 2 books for you. One, a smart book, written by then Vice President Al Gore, Earth in Balance. Have any of you read this? Amazing. All right? I learned a lot from this. It's not a political book. And a second one, World Without Ice. Have I mentioned this one before? No. When Al Gore got the Nobel Peace Prize for his work on the Earth's environment, so did a whole group of people working at the UN. And this author, Henry Pollock, a professor at the University of Michigan, A World Without Ice. Because there's a lot of skeptics out there. Have you heard it? You know, trees love carbon dioxide. Bullshit. Sounds good, right? I mean, trees love carbon dioxide. Come on. So it's amazing. So today, this whole class today, all about how we're affecting this planet. It's not pretty. But although you might be inclined to go home after this class, one more doomsday lecture by Dr. A, and just write poetry, this is not about doomsday. It's about awakening reality. We've got political leaders in this country that say global warming is a hoax. Throw me down in the gutter. Rick Perry and Michelle Bachmann. Huh? Throw me down in the gutter and walk over my head. Good God. We just came out of an ice age. We had a remarkable ice age coincided with the development of our species that went on for 2 million years. And it was one of several ice ages that the Earth experienced. We'll have an ice age lecture next week. And it wasn't a single event. It was up to 12, maybe 16 or more individual events where the ice came down, covered, obliterated, and then melted back. And it came down again and then rewarmed. And then it came down again. And it just pulled back for the last, most recent time, 10,000 years ago. So we've been warming for 10,000 years. Don't tell me the Earth is not warming. We just came out of an ice age. All over Boston, you can find glacial erratics. Come on. Where's the glaciers now? They're gone. We warmed. And then, about 1,000 years ago, we plateaued off. As I'll show you. And then we had a warm period in medieval times. And then around 1700, we had a little ice age, small. It plateaued off. And it started about 100 years ago. Holy God. The earth has been warming in the last 100 years at a rate that the earth has never, ever seen. And all the times the earth has warmed and chilled and warmed and chilled. The last 100 years it's warming at a rate the earth has never seen. What's going on? Yeah. Lots going on. All right. Look at that. Where is this? Where is that?
New York.
Yeah, New York City.
Just wondering what the role aerosols have played with cooling down the atmosphere.
Aerosols are very important. And at times they do help cool down. And then they wash out. Some aerosols that are mostly volcanic. Others that are human-made. Okay? When Mount Pinatubo erupted, the volcanic aerosols and dust were so effective that it reversed the warming for 1 year. And then we've made up for it. All right? Yeah, New York City. This is pre-Twin Towers. This is back in the 60s. Look at the Empire State Building, Central Park, the Hudson River. Holy God. The air's polluted and the water's polluted. Look at all the algae. The water polluted with sewage and runoff from fertilizers and chemical industries. And look at the air, foul. I remember this. You could walk through the streets of New York City in the 50s and 60s and into the 70s, and you come home at night, you'd have a ring around the collar of your shirt. So that laundry commercials on the early television sets, I remember when they were invented, would have ring around the collar, ring around the collar. Oh, it's a horrible thing if you wash the shirt and you still have a ring around the collar. We don't get rings around the collar. You've never heard that saying, right? Yeah, how about that? Look what we did. And no greater polluted place in the world than my LA. This is what it looked like. In 1953, you couldn't see across the town. There were huge mountains behind LA. For most of the year when I arrived in the 1970s, you didn't know they were there until the wintertime. But now, the air's really good. It took good laws. This is what we've been able to do in developed countries. In developing countries, they can't afford this very easily. Go around. So the background of Mexico City, from Al Gore's book, he has a chapter 3 called Buddha's Breath. In the time of this hour, or much less, we're all breathing each other's air, Bobby. Yeah, I mean, think about it. If I sat up here and lit a cigarette and puffed it out, how soon would all of you smell it? Right? Right? We're all exchanging each other's air. So the air that we are breathing, Al Gore wrote, is the same air that Muhammad breathed, Jesus breathed, and Buddha breathed. Same air. Wow. Except it's vastly different now. The air today is choking with sulfur, chlorine, fluorine, many chemicals that were not in that air that Buddha and the others breathed. All right, so you look around, Poland, Romania, Czechoslovakia, Ukraine, when the Berlin Wall came down, before you were born, it exposed the industrial combustion of Eastern Europe. Mexico City, Bulgaria, Beijing. How many? There's several from Beijing, right? Where are you, Beijing? No? God, I've seen that air. I've never seen such brown air. You can't see down the street. You know? Wow. But look at that. Not just China. It's Eastern Europe. Oh, look at that. Here, Brazil. So, what's doing all this air pollution? Well, there's two kinds. Only two. Combustion and photochemical. Combustion is when you burn stuff. All right, so you're burning carbon dioxide. When you burn methane, you're oxidizing. Light a match, light a wood, light coal, light gasoline, you're oxidizing it. And what you're producing is carbon dioxide and water. Now, methane, I have as an example, is actually the cleanest fossil fuel because it's mostly hydrogen, CH4. So it produces actually a lot of water and some CO2. But you turn around and burn another fossil fuel, like coal, it's mostly carbon. And the CO2 output is huge. It already looks huge just with methane, but think about that. How many of you have homes somewhere where the stoves are in oven or natural gas? Yeah. Do you vent that? Do you vent it? No. No, you sit there and cook a whole dinner. Run the oven as well. You might have a vent for the odors coming off that fine cooking you're doing, but we don't even vent. What about a charcoal stove? Charcoal grill. What if you brought that inside? What would happen? What if you brought charcoal grill inside? What would happen? Yeah, you're dead. In fact, you're committing suicide. Okay? So it depends on what you're burning, but they're all producing carbon dioxide. If they got sulfur in them, that's going to happen as well. Photochemical, there's only one. Only one. And I like it. A lot of you are taking notes. Some of you are typing in your computers. Only one photochemical pollutant, and it's ozone. It's ozone. O3. We live in an environment that we love O2, but O3 needs sunlight to form. I'm going to show you. And it's highly reactive, highly oxidizing. It'll burn your lungs. So there's ozone. Ozone is created from nitrous oxide, so it's a kind of a double-step reaction. Nitrous oxide is combustion. Most of our air is what? Nitrogen. And when I burn air, when I burn a match in nitrogen, not only do I make CO2, I'm burning the nitrogen. So I'm making nitrous oxide. We love nitrogen. Plants love nitrogen. But nitrous oxide is a poison. And a greenhouse gas. Double wham. And then you have the nitrous oxide, which gets hit with ultraviolet radiation, and it knocks off one of the oxygens to NO. And a free oxygen is created. That free oxygen is like Jerry Maguire. Jerry Maguire? What's the name of that movie? Jerry Maguire. Jerry Maguire had a funny saying. He couldn't stand to be... Have you seen the movie? No. Couldn't stand to be alone. Couldn't stand to be alone. And so what Jerry Maguire would do, or the free oxygen would do, look around, I'm free, I got to find another one. And so it finds an O2. Boom. There it is. And it makes ozone. Ozone is highly reactive and oxidizing. It burns. It is so oxidizing, it destroys plastic and rubber. Weird. And your lungs. It's unstable. It takes sunlight to make it, and it'll break down as soon as the sun goes down. So we'll see more of this. So air pollution from combustion, carbon dioxide, carbon monoxide from fossil fuels. Carbon monoxide is more toxic than carbon dioxide. Sulfur dioxide from burning sulfur-bearing coal and oil. Nitrous oxide I've just described. Soot, free ring around your collar, free carbon, particulates, fluorine and chlorine. And you take all of these and mix them with water, and look what you get. All acids. All acid all the time. They're all acid. Holy God. Carbonic, sulfuric, nitric, hydrochloric, hydrofluoric. So we're doing all this. It's a double hit. You're making really bad stuff in the air, and then the water droplets come in. You precipitate rain or just a fog, even a snowfall. You mean snowflakes come down like acid? Yeah. Okay, got it. And the extent, this came out of Al Gore's book. We can talk about local, like in my little LA. Regional, where Pittsburgh smoke goes all the way across New York and up into Labrador. That's regional. You have regional smog here, as I'll show you, in New England, coming out of Pennsylvania, Pittsburgh area, and New York City. Look at that. And then global. Globally, the pollution is that we've got greenhouse gases like carbon dioxide that are filling the entire atmosphere of the Earth. All right? So, Clean Air Acts. The Clean Air Act started in the late 50s. There are others in the 60s. But the really big one I want you to know, and the most effective one up to that time, was the 1970 Clean Air Act. All right? Global warming at the time was really an unknown entity in 1970, but we knew we were choking our cities. Everybody was getting sick, and asthma and lung cancer rates were off the charts. People were dying. Oh, wow. So Earth has changed. You know, the early Earth, air. Where did air come from? What did we learn? Volcanoes, yeah, volcanoes. And so the Earth, you only have Venus, Earth, and Mars, like the three bowls of chili, and Venus is still breathing out. Woo! Mars is dying. But the Earth breathed out, made its atmosphere, then began to breathe it in. All right, our Earth's atmosphere used to be 300 times thicker than it is today, mostly carbon dioxide, and the Earth breathed it in and turned it into stone, what this building is made out of. Leaving behind an air that was much thinner, not so oppressive, mostly, as you said, nitrogen, then 21% oxygen. Thank goodness we don't live in a 100% oxygen atmosphere. Can you imagine lighting a match and a cigarette? Would you do that? In a 100% oxygen atmosphere? Bang! Some argon, so that's 99.9% of our air, right there. The leftovers are really important because it's the leftovers that are affecting our climate. Water vapor, less than 0.1%, is the next most abundant. And then the really small numbers. In green are the greenhouse gases, 380 parts per million carbon dioxide. That's all? That's all? I mean, I'm worried about 380 parts per million. It's a very trace amount. It's really affecting us. And then 1.6 part per million methane. Yeah, that's the next biggest one. Methane is even a more powerful greenhouse gas, but it's much less abundant by a lot. But that little bitty amount. That's why if suddenly we double methane, we're working with small numbers. The effects are astounding. And we can't get this country, developed, powerful, rich, to sign an accord to control CO2. We have failed at every Earth summit. Wow. So the Earth's CO2 cycle, partly organic, breathed in by plants, released by animals, including us, and biologic decay. There's the chemical side, breathed out by volcanoes, in by our oceans. Both were basically balanced until we begin to affect the Earth with the onset of the Industrial Revolution. Started about the year 1800. Whoa. Whoa. All right, so we made improvements in first world countries only. Ozone, largely coming right down. We don't see these alerts anymore. Asthma mostly ended. All right, particulates are mostly scrubbed. We put big scrubbers on top of chimneys. We shift to other ways to warm things. We put caps on the gas. When we go get gas, there's a gasoline at the pump. We put a catch there. Acid rain has come down, but getting worse. The ones that affect our temperature of our planet because they're all greenhouse gases. Getting worse, getting worse. Even though we put on catalytic converters, that does help. Catalytic converter on your exhaust helps burn the carbon monoxide, because I told you it's worse, and change it to CO2. That's better, but it's still CO2. Okay, that's what a catalytic converter does. Converts CO coming out of burning gasoline to CO2, but it's still there. All right, so it's there. And then the acid rain. Now we measure rain, as you know, on a pH scale. It's a logarithmic scale. What is neutral? What's the pH of neutrality? 7, there it is. And so it turns out that rain is naturally acidic. Rain is about 5.6. Isn't that funny? It is. We love rain. Somebody ought to be, how come nobody sells rainwater? I don't know why not. It's great water. But it is naturally acidic. It actually dissolves limestone. You've been dropping acid in lab this week, right? Now when rain comes down, it actually dissolves. Yeah. Come with me to the cemeteries of Boston. And you'll find that the marble gravestones, if you look at them, they're hard to read. Because rain is naturally acidic. It dissolved. Like you in lab dropped acid on limestone and made it bubble. You dissolved it. Right, freeing up carbon dioxide that was in that calcium carbonate forever. Woo, let it out. Genie's out of the bottle. Genie's out of the bottle. All right. So, but when you now have an atmosphere that's putting out all these combustions, then the pH comes down below normal, below 5.6, that's what we call acid rain. And you know, we've got lakes in the Adirondacks, no fish, because it's too acidic, all right? Evergreens are very much affected because they're out there trying to do photosynthesis all year, all right? So it's that, and it's a New England thing. There's the areas, look at that, right on top of us, here we are. Go Red Sox. Ooh. Wow, it's our problem.